Good morning, students. Today we will discuss some more problems of exercise 5.1. Question is find all the point of discontinuity of the function fx is equal to 2x plus 3 and when x is less than 2, and 2x minus 3 if x is greater than 2. Now here you can see that the value of function varies as x changes from less than 2 to greater than 2. So at this point x is equal to 2, we will check the continuity of the function. So first we will take the value of f2, means the value of function at the point 2. So as you know that the value of function is 2x plus 3, so we'll put 2 at place of x, so we got the value of function is 7. So f2 we got the value of function at 2 is 7. Now we will find the left hand limit. The left hand limit, as I told you earlier, that we will have a lower point, a slightly lower point than 2. So we'll take it as x tends to 2 minus h fx. Now 2 minus h means x is slightly less than 2. So for less than 2 we have the function 2x plus 3. So we will put the value of function is 2x plus 3 here. Now we'll put 2 minus h at the place of x, so the value of function become 4 minus 2h plus 3. Now put at h tends to 0, that means h is 0, so we'll have 4 minus 2 into 0 plus 3, that is equal to 7. Now the value of function, the lower limit is 7. Now we will find the right hand limit. For right hand limit you put x tends to 2 plus h limit. So 2 plus h means the value of x is slightly greater than 2. So for any value greater than 2 we have the function 2x minus 3. So we'll put 2x minus 3 at the place of fx. So now limit s tends to 0, you will put 2 plus h at the place of x. So 2 into 2 plus h minus 3, which is limit s tends to 0, 4 plus 2h minus 3. So putting h is equal to 0 here, we will get 4 minus 3 is equal to 1. So the right hand limit is 1. Now as you can see that the value of LHL, means left hand limit, is 7 and the value of RHL is 1. Now since LHL is not equal to RHL, so fx is not continuous at this point x is equal to 2. So this point x is equal to 2 is the point of discontinuity. Now further we will check more points. So that we have taken a point C which is less than 2. Now you can see that as in the question, it is given in the question, for any value less than 2 we have the function 2x plus 3. So we'll put c at the place of x, you will get 2c plus 3. So left hand limit, or you can say that the limit at this point also we have 2c plus 3 which is equal to fc. So for all the points which is less than 2 the function is continuous. Similarly we will check the continuity at a point c which we have taken as greater than 2. So we will also find here that the limit exists limit, so the function is continuous at all the points which is greater than c. So therefore as we have solved the question, so we got that there is only one point at x is equal to 2, the function is discontinuous. Now similarly we will solve one more problem of the same exercise. And now here we have the function given fx is equal to mod x upon x if x is not equal to 0 and the value of function is 0 when x is 0. Now as I told you earlier, or in the previous class, you have learned that mod x we have two values, minus x and plus x. Minus x we take when x is less than 0, and plus x we take when x is greater than equal to 0. Now we will check, since the point is given x is equal to 0 or not equal to 0, so this is the point given to us. We will check the continuity at this point. So we will take at x is equal to 0. First we will find the value of function at this point, f0. Now since x is 0, then the function is 0, so we will have at f0 is equal to 0. That means the function is 0 at x is equal to 0. Now we'll take the left hand limit. Left hand limit we'll take at limit x tends to 0 plus h. We are finding the limit at point 0. So limit x tends to 0 minus h fx. Now we know that the function is 0 minus h, means if x is not equal to 0. For not equal to 0, we have the function mod x upon x. So we'll take the value of function mod x upon x, 0 minus h. Now since 0 minus h means it is less than 0, so less than 0, for less than 0 we have the value of mod x is minus x. So at place of mod x we put minus x upon x, will remain same. Now we'll put the value of x, 0 minus h, then h tends to 0. By solving this you will get the limit is minus 1. The value of LHL is minus 1. So now we will find the RHL. RHL, you can see that we'll put a limit x tends to 0 plus h fx. Now since 0 plus h means not equal to 0, so the value of function is mod x upon x again. So now as we know that the value of mod x is x when x is greater than 0. Now since 0 plus h is more than 0, greater than 0, so we will put x at the place of mod x upon x. So by putting x, value of x is 0 plus h, we will get limit h upon h, h tends to 0, h upon h is equal to 1. So now as you can see again that the value of LHL was minus 1 and the value of RHL is plus 1. So left hand limit is not equal to right hand limit, so fx is discontinuous at x is equal to 0. For all rest of the points the function will be continuous. Thank you so much.